So for any errors you make, please do the correction. And end of the class, you must upload the solution. Okay, I see 2 students still raising their hand. Any question?
Miss, if got marking error, then how? Contact you later.
If you think there is an error, you talk to me in the personal chat, maybe after the class.
Okay.
Okay, so if you found any calculation error or marking error or which part that you have a doubt, then you just send me a message in the personal chat after the class. Okay, so even you send it now, I will also check after the class. Okay. Start, you say you can't see the whole page. So maybe you should scroll to the left or right. If you still can't able to see, then maybe you liaise with me in the personal chat. Okay. Is it the mark papers can be downloaded? Guys, I'm not sure. Is it the mark script can be downloaded?
Yes,
Hey, Miss,
can be
I got it already.
Okay, can be downloaded. Okay, Saad, maybe you can download it and then you check it. Okay. So Saad, try to download the paper. Okay. Okay. Now, let me proceed. Samuel, you still have question? First, you're raising your hand. Sutesh, you have question?
No, miss.
Okay. Because you still raise your hand. Okay. Okay. Now, we continue with questions 3B. So this one is questions 3B. Okay, so for questions 3B, right? Okay. A vertical area AB, 9.6 meter high, stands on ground which is inclined 12 degrees to the horizontal. Okay, so 12 degrees to the horizontal. So a stay connects the top of the area A to a point C on the ground 1 meter downhill from B. Okay, the foot of the area. So determine the length of the stay, the angle the stay makes with the ground. Okay, so now let's draw it out. Okay, so what is the problems that we have right here? So now the vertical area, okay, so the area is vertical with this height. So that means this is the area, 9.6 meter. Okay, so they write it as a, they give you as a AB. Okay, then stands on the ground, which is inclined 12 degrees to the horizontal. So the ground is actually inclined 12 degrees to the horizontal. So that means, let's say this is a ground. Okay, so when the ground is inclined 12 degrees to the horizontal, so that means this is 12 degrees. Okay, to the horizontal. The ground, okay, the ground is inclined 12 degrees to the horizontal. Okay, so a stay connects the top of the area A, the top of the area A is here, to a point C on the ground, okay, which is 1 meter downhill from B. Okay, so we have another point C on the ground. Okay, so let's say this is point C, connect to top of the area A. So this is C. Okay, so the point C is actually 1 meter downhill from B. So that means here is 1 meter. Okay, then here is 9.6, here is 1 meter. Okay, the foot of the area. Okay, so determine the length of the stay. Okay, so which one is a stay? So this one is a stay. The one for blue color is the stay. Okay. Okay, so this one is a stay. Okay, so that is a problem. Okay. Okay, now So when we look at this, okay, since it is a 12 degree to the horizontal, okay, so so since this is a 12 degree to the horizontal, so that means the degree here is 102. So this is not a 90-degree triangle. Okay, it's not a 90-degree triangle. So please take note of this one. So I think with this triangle, now you can work on the rest of the part, right? Okay, so start from part 1. Okay, guys, everyone do the correction. Later have to upload the correction. Okay, so the length of the stake, so you need to find AC lah, right? Okay, so you need to find AC. Okay, so now, if you wish to find AC, and can you see the corresponding angle is 102? Okay, then you have the length of the two sides of AB and BC means we can use the cosine rule. Okay? So that means AC square is equals to 1 square plus 9.6 square minus 2 times 1 times 9.6 multiplied with the cos 102. Okay? Then you just find what is a value and you just find the AC. So the AC is 9.86 meter. Okay? 9.86 meter. Okay. Now, okay, so that's how we get the answer. Okay, so as I say, once you get the triangle, you know what to do. But I do realize, okay, many of you draw the triangle, but there are some things wrong with the angle. So means you don't really understand the questions well. Okay, Saad, we deal with your issue later. Okay. Okay, so Saad, you make the correction first. Okay, you take. Okay, there are suggestions from others. Because sometimes my view and yours view is different. Okay. Okay, part 2, the angle the stay makes with the ground. Okay, so you need to find the angle of C. Okay, so the 12 degree is actually for this one, right? So now you need to find the angle for C. That means you need to find this angle. Okay, so to find the angle C, you can use the sine rule already this time. Okay, so okay, then okay, sine C, you need to find the angle C here. Sine C, corresponding angle is 9.6. Okay, then we have another angle 102, right? Then divided by the length of the stay, we found it in the first part. Then you can solve for the C. Okay, so the solving part, I leave it to you. Okay, so guys, can you see when you did wrong for part 1, okay, I will still giving you some marks for the correct working. Okay, so I also give you marks for workings, correct working. Okay, but those assume is a right angle, right triangle, so sorry, I can't give marks for that. Okay, so but for the rest, angle got it wrong, so you get penalized in part 1, marks deducted, but part 2, I still give some marks for workings. Okay, okay, so any questions for question 3B before I move on? So those get it wrong, can you understand right now?
Yes, miss. Can you
Yes,
just
miss.
can you just keep it?
Sorry, someone says.
Can you just keep the no? Don't scroll down. I'm just writing.
Okay. Oh, you can screenshot as well.
Yeah, okay, miss.
Okay. Yeah, I will discuss 4. Okay, since there's a request for 4B, then I will do both 4A and 4B. Okay, so now for questions, done? Just now for asking me to stay with the page. Have you do the screenshot?
Yeah, I got a screenshot, miss. Thank you.
Screenshot, okay. Next is a question for 4A first. Okay, in an alternating current circuit, voltage of V and current I is given as the trigonometric function. Determine an expression for the instantaneous power P at time t given that P equals to VI. Okay, so for this one, you may not understand. I may not understand that as well because we need some backgrounds on the engineering to understand this part. Okay, so that is not my area also. But can you see this is actually, you may not really know about this. Okay, what is means by the instantaneous power. But can you see what they ask you to solve? They already give you then P equals to VI. Okay, they already give you P equals to VI. You have a V, you have a I. Okay, then you just need to express the P, okay, as a sum or difference of sines and cosines. Okay, so I'm not sure whether you can still remember. Okay, so when we did the trigonometry, right? Okay, I have discussed questions before. Okay, and it's also in your tutorial question. Okay. Can you see this is a formula, okay? How we change the product of sines and cosine into sum or differences, okay? So this is the one, and I have discussed this, okay? So it's actually about this question, okay? It's about this question, and we have discussed a similar questions in the tutorial, okay? Okay, now, so back to the questions here, right? Okay. So you need to write it as a difference of sines and cosine. And actually, I provide this formula as well. Okay, so you can see it here. The formula is provided here. Okay, then come to the first. Okay, you need to find P is given as a VI. So V is 8 sine WT multiplied with 16 sine WT minus pi over 6. Okay, so this is the multiplication, right? And then can you see we have 8 and 16, so we can multiply. So when we multiply 8 and 16, we get 128. So I have sine WT product with sine WT minus pi over 6. Okay, so now can you see we involve the product of sine WT and the product of sine WT minus pi over 6. So when you look at here, that means you're supposed to use this, okay, formula to actually change the product to the sum or difference, okay? So when you look at here, can you see this is alpha and beta? So this is your alpha and also this is your beta, okay? Alpha and beta. according to your formula. Okay, so now you still have a 128, right? Okay, then when you use the formula, there's a half. Okay, still have a half. Then you open the bracket. Okay, so we can convert it as a cos alpha minus beta. So your alpha is WT minus with WT minus pi over 6, the beta. Okay, then minus with cos alpha plus beta, so sine, WT plus WT minus pi over 6. Okay, so can you see this part? We just substitute the formula. Okay, then cancelling down 128 and half, so which is a 64. Then simplify. Okay, so I have cos WT minus WT is a 0, then minus minus plus, so cos pi over 6. Some students have some minor error, okay? So on the sign, okay. Then after that, for the second part, okay, so this is a bracket. So cos WT plus WT is 2WT, then minus with pi over 6. Okay, so that's the answer. Okay, if you can give this answer, you get the full marks already. So is that okay? Okay, Saad, there's questions and others help me to answer already. Yeah, thank you. Okay. Okay, so is that clear for 4A now?
Yeah, clear, Miss.
Okay, do the correction. Thank you for the feedback. Then I would like to continue for questions 4B. If you have a problem to solve the equations for trigonometry, I'm actually quite worried. Okay, so why I can hear myself talking. Okay, so I think when come to complex numbers, you may need to do some recap for the trigo before I continue already. Okay, then let me continue it here.
Miss, I'd like to
Yes.
ask something about 4B. Do I need to do the correction for the whole question? If only my final answer is wrong.
Only your final answer is wrong. Okay, you still have the paper, right? You just make the correction on the final part. Then
Okay.
when you snap the photo, you don't need to rewrite everything. Yes, you just correct the error part. Okay, then you just snap the photo for whole question, right?
Okay.
Yeah, you can just do the correction on the papers that you your script. Okay. Okay, so for questions B, right? Okay. 5 secant t plus 2 tangent square t equals to 3. Okay, when we want to solve this kind of the equation, you have to make sure you have the same trigo. Then you can factorize it. Okay, then we can actually use the trigonometric identities to actually make it as the same trigonometry. Okay, so which one we should replace? Okay, so we have secant, we have tangent. So either the whole equation must be a secant or whole equation must be a tangent. But we have identities for tangent square t, which is involved the secant t. So if you refer back to the trigonometric identities, the one involved tangent square and secant, which is this one. Okay, so this is the trigonometric identities that you should use. Okay, So that means you just substitute tangent square theta equals to secant square theta minus 1, right? From the identities. Then for 5 secant t plus 2 times secant square theta minus 1 equals to 3. Okay, then you just need to simplify this and you will get 2 secant square theta plus 5 secant t. Oh, sorry, I should put it as a t, not theta. Then minus 5 equals to 0. The right hand side must be equals to 0 since we need to factorize it. Okay, so this can't be factorized, so we need to find the secant t by using the formula. Okay, so remember the formula is minus b plus minus b squared minus 4ac divided by 2a. Okay, so you substitute with the b, which is 5. 5 squared minus 4a times 2 times c, negative 5, divided by 2a, 2 times 2. Okay, then you calculate the value. There are two values here, 0.7656, or the other's value is negative 3.2656. Okay, so these are the two values. Okay, so now, okay, for the first value, for secant t equals to 0.7656, okay, if you need to solve this, right, okay, it will be equals to t equals to arc secant of 0.7656, and since secant is actually equals to 1 over cos, so to find arc secant is actually equals to arc cos of 1 over 0.7656. Okay, however, for this one, right, since the arc cos value is greater than 1, the values here in the bracket is greater than 1, so you can't able to solve it, okay? So there is no solution, okay? So for this one, no solution. No solution for t equals to arc secant of 0.7656. Okay, so if no solution for this one, then it's okay. We just move on to the next one. Okay, then we proceed for the second value. Okay, for second value for secant t equals to negative 3.2656. Okay. Okay, remember, okay, when we want to find, solve the trigonometric equation for the angle, right? I always ignore the sign first, okay? Even though this one with the negative, but I will ignore the sign for now, okay? So that means I will try to find the basic angle, okay? We'll try to find the basic angle first. What is means by basic angle here, okay? That means the angle that is in the first quadrant, okay? The angle that is greater than 0 or less than 90 degree, okay? In the first quadrant. We solve the angle in the first quadrant, okay? So now, okay, that means we would like to find the t arc secant, sorry. Okay, so we will find the arc secant of negative 3, sorry, no negative, okay, I just mentioned. Okay, 3.2656. And remember, this is equals to arc cos of 1 over 3.2656. Okay, arc cos of 1 over 3.2656. And when you calculate the angle, you get 72.17. Okay, so always remember when you find the values here, okay, we don't put the sign first because you want to get the basic angle. Okay, basic angle. So now, okay, for the second of negative, okay, so since the second is about the cos, so cos is negative in which quadrant? Okay, so remember the sign, right? All science teacher are crazy, okay? So since second is at cos, we are referring to the cos. So cos is positive for the first and fourth quadrant. So that means cos is negative in the second and third quadrant. Okay, so this is in the second and third quadrant. Okay, second and third quadrant. Okay, then now, so let's proceed. So what is your T? Okay, since just now we say in the second and third quadrant, okay, this is an angle of 72.17. So for the second quadrant will be 180 minus 72.17. Then for the third quadrant will be 180 plus 72.17. Okay, so the correct answer should be 107.83. Make sure you understand this concept, okay? Okay, Saad, as I say about the papers, you put it in the personal chat. Okay, so because this is an assessment, you put it in the personal chat. Can you liaise with me in the personal chat? Okay. So 252.17 degree. Okay, 252.17. Okay, so sometimes I will give some of the, how to say, because working is actually given, so maybe your final answer is correct. If let's say some of the working is incorrect, so certain marks will be deducted, or maybe certain important working is not complete, so you may not get the full marks. Okay, but if you have a doubt, it's okay. You screenshot, you put it in the personal chat, then I will check it out later. I will clarify for you. Okay. Okay, so that's how we solve it. Okay, for this question. So
Miss,
that
can you scroll left, please?
is this the
Can
part?
you make it like all of it? Yeah, yeah. I just want a screenshot.
Okay.
Thank you, Miss.
Okay.
Miss, can you scroll up? I just want to double check the 4A final answer.
4A.
Yeah. Okay, can in.
Okay. So any doubts? Any other doubts? Okay. Okay, class. What is the reason that you should not include the negative sign over here? Okay, so when you include the negative sign, okay, let me explain this one. Okay, why you don't include the negative sign here? So when you include the negative sign, your calculator will give you this answer. Okay, your calculator give you the answer. Okay, and which this answer is in the second quadrant. Okay, but for since the questions my questions required the angle, all possible angle between 0 to 360. So for the second that is a negative, it can be in the second and also third quadrant. There are two possibilities. But the calculator, they actually give you one answer. They give you the answer in second quadrant. Okay, so since there is one possible, if let's say you just ask to find until the second quadrant, okay, so you can include the negative sign and get 107.83. So you get the answer. But now you need to find any possible angles between 0 to 360. If when you include the sign, the calculator only give you the second quadrant. Okay, so that's why we don't include the sign. Okay, so if we don't include the sign, they will always give you the answer in the first quadrant. So when you have the answer in the first quadrant, then you can actually use the basic angle to actually look for the angles if let's say it is in other quadrant. So you get my point? Okay, you get my point? Because your calculator will give you the second quadrant, the answer in second quadrant. Okay, so if you want to find the basic angle, we don't put the sign. Okay, if you put the negative sign, can you see first quadrant is all positive? If you put negative sign means they will give you the angle in other quadrant. Okay, so that is the reason. Get it? Right, okay, and I can see the arrow because students include the sign, they get 107.83, the angle in the second quadrant. So they take it as a basic angle and they use it to do the calculation. So at the end, is wrong. Okay? Okay, any questions you want to clarify? Please do it now. Okay, so I don't see any other thing. So is that clear, students?
Clear, Miss.
Okay, then as I say, screenshot the images of your correction and upload to the this team. Okay, so for this team, right? For this channel, week 6. I already create a folder for the correction of the class test 1. Okay, correction of the class test 1. So please upload your correction there. Okay. Okay, so just now Ziyi never responds to me. Ziyi, have you checked your script? Ziyi, have you checked your script? No response from Ziyi. Okay. Okay, never mind. Okay, so since you don't have any other question, as I say, yes, Kaifeng? About the marking of the script, you liaise with me in personal chat. Is mouse not working? But can use a touchpad in the laptop, right? You still can type, right? It's not the keyboard problem. Using PC. Oh, okay. I see. Okay. Mouse not working. Then he say he checked already. He texts you in the phone, is it? Okay. Okay. Ziyi, you can also use your handphone. I'm not sure whether your handphone have team apps. Okay, then will be convenient. Okay, but you need to settle your case. Okay, mouse not working for PC. Then a lot of things you can't do. Okay. Then now I will just move on. So I would like to Okay, then I think I give you a short break, okay? Then after that, we'll continue the lecture, okay? For the last two topic, which is a Gaussian elimination method, and also the Cramer's rule, okay? So I give you 10 minutes break, okay? Okay, so I will see you after 10 minutes, then we continue with the lecture, okay? Okay, students, let's continue. Let me take the attendance first. Today is lecture. Okay, so Saad, as I put in the personal chat, we will discuss about your case after the class. Okay, so okay, guys, I think I want you to understand some things here. Why I give you all half an hour additional time to upload the questions. Okay. To be frank, if we just say upload the question, snap the photo, upload the question, I think we can get it done within 10 minutes. Okay, so even though I give a half an hour of the time, okay, for my other classes, right, I do realize that the students, they don't actually start to compile the file, fully utilize the half an hour. So, for example, the additional time given, then the submission due is 5:30. Students always submit last minute. This is one thing. Okay, so why we give a half an hour? Okay, so to be frank, the half an hour is including taking photo, compile it into the file, and after you compile in the file is in your laptop, right? Okay, so you need to check, is it all the images are there? Okay, so is it arranged properly according to the sequence? So it's your responsibility to make sure that all the images solutions are there, then you upload the file. So it's your responsibility to make sure the file you submit is correct. Okay, so that's why we give you half an hour. Okay, so else I may just give you 10 minutes. 10 minutes may be enough already. Okay, to snap the photo and upload. And also the half an hour, right, is also, you know, when we have maybe all students, your group is not that big yet, okay, only 14. So we may have all 14 students submit almost the same time. So for Moodle, maybe sometimes they need time to upload, or maybe the internet. Yes?
Ma'am, sorry to disturb you, ma'am. I accidentally upload the question one I have done on that day, but it's happened to me for the first time. I just forgot to upload question one. Ma'am, please reconsider it. I'm not lying.
Okay,
I just forgot.
so Saad, I will talk to you after the class.
Okay.
After the class, I will start a call with you in the personal chat. Okay? We will have a call in the personal chat. Okay? So what I comment just now is for everyone. Okay? So to ensure that for the coming test 2 and exam, this is not happen again. Okay? So to be frank, I deal with many assessment, including other classes. Okay? So I have to tell you, okay, it's your responsibility to ensure that the submission is correct. Okay? Okay, so I will discuss with you, okay, after the class. Okay, all students take the attendance already. And another thing, when I do the marking, I found there are 2 students, they don't arrange the questions according to the sequence. Okay, so I remember one student is Ziyi, Ng Ziyi. Make sure you arrange your questions according to the sequence. So it will make me easier for the markings. So I don't want to see like maybe question 4 on the first page, then question 3, then 4A first page, 4B last page, question 1 in the second page, question 3 in the third page, these kind of the things, okay? So it's very difficult, okay? So you take note, there's another one more students I couldn't remember, okay? But you yourself will know, okay? Okay, so now let me continue the class. Okay, Saad, take note also, okay? Okay, let me continue with the matrices. Okay, now, okay, remember as I say, there are 3 methods to solve the 3 by 3 3 unknowns of the for the simultaneous equation with 3 unknowns. Okay, so that means when you need to solve the simultaneous equations for 3 unknowns, you require the 3 equations here. Okay, like what you can see right here. Okay, first, second, and third equation. X1, X2, X3 are the unknowns. Okay. So can you see X1, X2, and X3? Okay, so these are the unknowns that you need to find the value. Okay, so how we actually solve it using Gaussian elimination method? Okay, then for the 3 equations here, first we will present it in the augmented matrix. Okay, so what you are seeing right here, okay, this part we call it as an augmented matrix. Okay, so can you see this is a matrix, right? And we put a straight line. Okay, so for the straight line that we put, right? Okay. So for the coefficient of the equation, okay, the coefficient of the equations, we'll put it at the left. Okay, in the total, we have 9 coefficients here. Okay, then for the values at the right-hand side of the equations, we will put it at the right of the straight line. Okay, so this one we call it as augmented matrix. Okay, then we will apply the elementary rows operation. So this one we call it as elementary row operations. Okay, elementary row operations to actually okay, conduct the elementary row operation so that the augmented matrix that you have just now have 3 zeros here. Okay, 3 zeros here. And what we call for this kind of the matrix, okay, for this part, okay, with the 3 zeros here, okay, below the diagonal entry, we call it as upper triangular. Okay, the one that we learned earlier, upper triangular. That means, okay, so you have 3 zeros below the diagonal entry. Diagonal entry is this row. Okay, so below there are 3 zeros. When we have 3 zeros here, right, then we can proceed to actually solve the simultaneous equation. Okay, so when you have 3 zeros just now, okay, when you get the upper triangular, okay, when we have an upper triangular, then this is our equation. The simultaneous equations become this. So when you look at the simultaneous equations, okay, then first, second, third equation. The third equations, we only have one unknown. This is your unknown. Then when you have one unknown, you can solve for the values of x3, okay, in the third equation. Okay, so can you see the third equations already found? Okay, for the second equation, you have two unknowns, okay, x2 and x3. And just now, as I say, in the third equation, you can find x3. You can find x3. So when x3 already found, then you can find the values for x2 in the second equation. Okay, so for second equation, you can able to find x2. Okay, then now come to the first equation. These are the three unknowns, right? Okay, so from the third and second equations, we already found x2 and x3. Then when come to first equation, we can find x1. Okay, so this is the how we solve it. Okay, how we solve this. Okay, so for this one, since everything put in general form, you may find it difficult to understand this. Okay, so let's go through. Okay, let's go through this one. Okay, the Gaussian elimination method, augmented matrix. Okay, this is examples. Okay, so let's say for this example, okay, I think I need to go out from full screen. Okay, so for this equation, okay, so this is the simultaneous equations that we need to solve. Okay, right? So what you need to do here, okay, you need to put all the coefficient. So can you see x? X means there's a 1. Then followed by the coefficient 2 and 3. Then for second equation, we have 2, minus 3, and minus 1. So 2, minus 3, minus 1. For third equation, we have minus 3, positive 4, positive 5. Okay? Then for the values at the right-hand side, you will put it here. Okay? So make sure you have straight lines here. Okay? So this one is an augmented matrix. Okay? So when you got the simultaneous equation, you put it in this matrix. Okay, so what is the next? Okay, next one. For the augmented matrix, we got it just now. Okay, we are going to perform the elementary row operation. Okay, so this one we call it as elementary row operation. Okay, so remember just now I say we would like to change these three values to 0. Okay, so first we are going to change these to 0 first. Then followed by, we will start with the first column. Okay, changing the second value to 0 and followed by changing the third value as 0. Then after that, we'll go to second column and we're changing this value to 0. Okay, so this is a suggestion. So now, can you see, we start with the first column. We are changing our plan. Okay, our plan here is to change this to 0. Okay, by using the elementary row operation. So this one, we call it as elementary rows operation. Okay, so now, okay, for R2, okay, what is means by the R2 here? So the R2 here means now we are conducting the operation on second row. So can you see you have 3 rows, first row, second row, and third row. So this is R1, R2, and R3. Okay, so when here we put R2 means we are conducting the operation on second row. Then followed by column 2R1 minus R2. So what is means by 2R1 minus R2? That means you take number 2, you multiply with R1 first row, and then you subtract with the values in R2. Okay, you subtract with the values in R2. Okay, so this is means by the elementary row operation. Okay, so now let's look at here. Okay, 2 times R1. So can you see your first row is 1? So 1 times 2, right? Then minus with second row. Okay, so R1 times 2, you get 2. Minus with 2, you get 0. Okay, we get 0. Okay, then we need to do it for the whole row. Okay, it's not just the first value. Okay, then we continue with the second value. Okay, 2 times R1. So 2 times 2, which is 4. Then 4 minus negative 3. Okay, 2 times 2, you get 4. Then 4 minus negative 3. So 4 minus negative 3, you get 7. So you get 7 here. Okay. Then I continue, okay, with number 3. Okay, 3 times 2, 6. 6 plus negative 1. Sorry, 6 minus negative 1. So that means it's 7. We got 7. Okay, then we continue. 5 times 2, 10. 10 minus 3. So we get 7 as well. Okay, so can you see first row and third row are remain? Okay, so we just do on the second row. The row elementary row operations is only for the second row because of here we put R2. Okay, can you understand? Okay, and what is the purpose on doing this? We are making this to a 0. We are making this to 0. Okay, so is that clear so far? The row operation and how we get the value for second row?
Miss, can you repeat it, please?
Okay, so can you see when come to Gaussian elimination method, our purpose is to get these 3 values become 0. Okay, these 3 values become 0. So we will start with the first column. Okay, we are making this value to 0 first. How to make this value to 0? Okay, so that means now we need to involve the second row. Okay, second row. Okay, so can you see my operations here? Okay, I'm taking 2 multiplied by R1 minus R2. Okay, because when I'm taking 2 multiplied by R1 minus R2, I can get a 0 for this value. Okay, I can get a 0 here. Okay, so right now, so when can you see this one is 2R1 minus R2? Means 2 multiplied with R1, 2 multiplied with row 1 minus row 2. Okay, so when you look at this value, this is the first value in the first row. First row, number 1, you multiply 2. When you multiply 2, you get 2. And 2 minus 2, you get a 0. Okay, you get a 0. Can you see? I get a 0 here. Okay, then, okay, 2 multiply with first row minus second row. So come to second value. 2 multiplied by 2, you get 4. Okay, then 4 minus, because here required minus negative 3. So here is negative 3. 4 minus negative 3, you get a 7. Okay. Can you understand, students? Before I proceed.
Yeah, miss, it's clear now.
Okay. So you proceed, okay? 2 times 3, 6, minus negative 1. So which is 7. Okay? Then 5 times 2, 10, minus 3. So you get a 7 as well. Okay. Now, let's proceed. Okay? So, next, we want to make this to a 0. Okay? So we want to make this to 0. So since we want to make this to 0 and it is involved third row. Okay? So that's why here we involve the row operations on the third row. Okay? Third row. So how to make this to a 0? Okay? So that means we're taking 3 multiplied with the value of first row and then plus the third row. Okay? So now you look at here, the value is 1. Okay? 1 multiplied with 3 is a 3. 3 plus negative 3, you get a 0. Okay, you get a 0. Okay, so this is our purpose. We want to make this as a 0. Okay, then next, okay, so R3, huh? Okay, so come to this value. 3 times 2 is a 6. 6 plus 4, which is 10. Okay, next. 3 times 3 is 9. 9 plus 5 is 14. Okay? Okay, next. 3 times 5 is 15. 15 plus 3 is 18. So we get 18. Okay? So the operation is conducted on third row. Okay? So first and second row is still remain. Okay? And the purpose of the row operation we conduct just now is to make this become a 0. Okay, so done. Can you understand? Before I proceed?
Yes, miss.
Okay, okay, thank you.
Yes, miss.
Okay, thank you. Okay, so next, okay, so what is the next? So the next is we need to make this to a 0. Okay, we want to make this to a 0. So when we want to make this as a 0, again, we will involve the row operation on third row. Okay, so that's why here is a R3. Okay, R3. Huh? Okay, how to make the how we make the third row as a this 10 as a 0. Okay, then we should apply the second row. We should use the second row. Okay, why we use the second row? Because for second row, right, here is a 0. Okay, here is a 0. So when we apply second row on the third row, to do the operation on the third row, and this 0 will still remain as a 0. I cannot use the first row. If I'm using the first row to conduct the row operation on third row, then it will affect this value, the one that already become a 0. Okay, so, okay, now, so I'm taking 10 times R2, then minus 7 R3. Okay, 10 times R2 minus 7 R3. Okay, so that means how? Okay, look at here. Okay, so if we look at the first value, okay, 10 times second row, 10 times 0 is a 0. Okay, minus 7 times third row. So minus 7 times 0 also 0. Okay, so you get a 0. Still remain as a 0. We have to remain this as a 0. Okay, okay, then next, we continue with a second value, 7. 7 times 10 is a 70. Okay, 70. Then minus if 7 times third row. So third row is a 10. 7 times 10 is a 70. So 70 minus 70, you get a 0. Okay, remember our purpose on the operations here to get this as a 0. Okay, let's proceed. 10 times 7 is a 70. Okay, then 70 minus 7 times 14. Okay, 7 times 14 is a 98. So you get negative 28. Okay, then let's continue. This value, 10 times 7, which is 70, minus 7 times 18. 7 times 18 is 126. So we get negative 56. Okay, so what is the values we have here? Okay, basically is The operations here is to get the values here as a 0. Okay, is to get this value as a 0. Okay. Now, can you see we already achieved the upper rectangular? That means these three zeros, these three elements become zeros. Okay. Okay, now, can you understand for R3? Okay, for your information, right? It's not necessary that you must fix to this row operation. Okay, so you may have different row operation as long as you can able to get these three elements as a 0. Okay, your row operations can be different as long as you make these three values as 0. Okay, so individually you may not really follow exactly the same operations here. Okay, but as long as your final answers, okay, you can get these three zeros, upper triangular. Okay, okay, now what is the next? Okay, so when we get yes.
Then we have three methods for R3 for solving R3. We have two methods for solving row 3.
Okay, what is means by two methods?
For example, ma'am, you have to solve the row 3 by the first method, and secondly, you're solving the row 3 by second method. So we have to use both methods or only one method to solve the row 3.
Okay, so can you see the step? Are you referring to the step earlier?
Yes, ma'am.
Okay, so the step earlier is to get this become a 0. Okay, the step earlier is to make this become a 0. Okay, but another row operations on R3 is to make this become 0. Okay, so when you want to make this become a 0, you should using R1. Okay, you're using R1. It will be easier, okay, for this case to solve it, right? Okay, you should using R1 because R1 there's a value. You can actually conduct the operations to make this as a 0. But when come to the second 0 in the R3, right? Okay, in order to make this as a 0 and the first 0 still remain, then you must using the second row. Okay, you must using the second row and conduct the row operations on R3. Okay? Okay, so...
Okay, ma'am, thank you. Ma'am, can you solve, later on, can you solve that question so that we can understand?
Yeah. I have to proceed, okay? Okay, let me proceed. Okay, so can you see this is what we achieved just now? Okay, for the row operation, for elementary row operation, I managed to get this matrix. Okay, so after I get this matrix, right? Okay, then I will rewrite my matrix as this one. Okay, so can you see for this part, I put it here. Okay, then this is our unknown, x, y, z, our equation. Okay, so for you to recall back, so this is the equations that we need to solve. Okay, so this is the equations we need to solve, right? We need to solve for the x, y, z. So we write it as, okay, x, y, z, then equals to 5, 7, negative 56. Okay, so the 5, 7, negative 56 is actually come from here. Okay, then this one is actually written here. Okay, now, so let's start to solve for the x, y, z. Okay, we will solve it from the third equation, the third row. Okay, why we solve it from the third row? Because third row is actually telling you that the equation is negative 28z equals to negative 56. And third equation only have one unknown, which is a z. Then you can able to solve z equals to 2. Okay, z equals to 2. Okay, once I get the values of the z equals to 2, then I will go to second row. Okay, so second row will give me the values of 7y plus 7z equals to 7. Okay, so second row, which is giving you 7y plus 7z equals to 7. Okay, then can you see we already have the values of the z just now. So z is equals to 2. So since z is equals to 2, then I can able to solve for the y. Okay, earlier we already solved for the z, so we can solve for the y in the second equation. Okay, after we get z and y, then we will proceed to the first row. First row, we have 1, 2, 3. So which is 1x, 2y, 3z, and equals to 5. Okay, and from the earlier, we managed to get z as a 2 and y as a negative 1. Then we can solve for x, which is equals to 1. Okay, so can you see, when we make these three as a 0, when these three become the 0, then the third equation, we only have one unknown. The second equation, we only have two unknowns, and the first equation have three unknowns. Okay, so we'll start solving one unknown from the third equation, then followed by second equation, followed by third equation. Then we can manage to find all the values of x, y, z. Okay, so can you understand? Okay, what is the reason?
Miss.
Yes.
So the formula is technically set by you. You change the whichever one you want to make the 0, but the rows used are generally the same, right?
Yes. Okay. You're saying that the value is it the 10,
Yeah,
7?
Yeah,
Yes.
the 10, 7 and all this.
So all these values of 10, 7, and 3 is not fixed. It actually depends on the value in the matrix. Okay.
Miss, what about the plus and minus?
The plus and minus will also change. The plus and minus also change. Okay, because in your matrix, right? They can be different sign. So when there's a different sign, of course, your plus and minus will be different. Okay, so to be frank, because this one is some suggestion, the solution that's suggested. If come to me, right, I may solve it differently. You can see my row operation is different. Okay, so when come to the tutorial, the discussion, when we solve for other questions, when we do the discussion, you can see my row operation and yours rows operation will be different. But at the end, as long as if these three are 0, then it's fine.
Miss, so
Okay?
we need to own self come up with the formula here, like the 10r minus 7.
Yes, this one is come up by yourself. Yes. Okay, it's come up by yourself. Okay, it's because it will not always the same. Okay, it depends on the values in the matrix. So you need to figure out, okay, what is a row operation until you can get the 3 zeros there. Okay, until you can get the 3 zeros there. Okay, so never mind. Okay, okay, now let's say start from the beginning again. So for this simultaneous equation with three unknowns, first we will write it as a augmented matrix. All the coefficient at the left and the values at the right hand side of the equations, we'll put it at the right, and we separate with a straight line. Then after that, we are going to start with, we always start with the first column, and we will start making this, as a 0. So we conduct the operation on second row. Okay, so that we make this as a 0. Okay, then After that, okay, we will still continue with the first column. We would like to make this, the third value in the first column to be a 0. So we will conduct the rows operation on R3, third row. Okay, so after done, then we will proceed to second column. So when proceed to the second column, our purpose is to make this as a 0, which is this one. Okay, so we conduct the row operation on third row again. Okay, so once we get the 3 zeros here, okay, then we can proceed to solve for the x, y, z. Okay, so you should rewrite your equation, your matrix as this. Okay, then we will start to solve from the third row because we have one unknown. We can solve for the z. Then with the z value we obtain, we can solve for the y in the second row. Then with the z and y we obtained earlier, we can solve for the first row for the values of x. Okay, so we get the values of x, y, z. Okay, this is Gaussian elimination method. Okay, understand? Right? Okay. So, you will understand better when you practice the question. Okay, when you practice the question. But do you get the ideas now? How we use Gaussian elimination method to solve the x, y, z? Do you have the idea now? Okay. Yes.
What about the upper triangle? Is it also under the same rule? If you are to change it to the upper triangle,
What it means by I don't understand.
means you change the upper triangle to zeros. I mean you use a down bottom triangle rule. I think that's what you call it. Right?
No, this one we call it as upper triangular. Okay?
The other one is lower triangular, right?
You see, okay, hold on.
What I meant to say is, what if you change the other 3 to zeros?
Okay, we always, what you're trying to say is changing the top as a, instead of using upper triangular, you are saying that using the...
Yes, yes.
Changing the top value as a 0, is it?
Yes.
Okay, so if changing the top one as a 0, I guess we can able to find as well. Okay, because the concept here is when we have 3 zeros, we will have an equation with one unknown, then equations of 2 unknowns and so on. Okay, for your information, right? Okay, for your information, okay. So for the Gaussian elimination method, right? Okay. If you can, there is another way of doing Gaussian elimination method. Okay, here we just make these 3 as a 0. We just make these 3 values as a 0. But when come to last time when I taught another module for other group of students, when I teach Gaussian elimination method, right? So we are going to conduct the rows, elementary rows operation until we have the matrix become like this. Okay, so currently what I taught you here, okay, currently what I'm teaching you here, you're just changing these 3 as a 0. Then the rest is not 0, okay? But previously when I taught another module, okay, in another, not here, other modules, other college, okay? So when we apply Gaussian elimination method until we achieve this, okay? So until we achieve this means the diagonal values are exactly 1, okay? When we get the diagonal values are exactly 1, okay, let's say this one is 1, 2, 3. Okay, so once we achieve this matrix, Okay, that means all the diagonal is 1, the rest are 0. We can directly get the values of x as 1, y as 2, and z as a 3. Okay, so this is another way. Okay, we can also using this method to achieve this matrix, then we can directly get our values of x, y, z without solving the equation. Okay, but you need to apply the rows operation. The rows operations can become quite complicated already. If you also want to make these three values as a 1 and these three values as a 0, just for your information. Okay, just for your information. If you look for the, maybe when you do online study in the future, you may find that, hey, how come some Gaussian elimination method is like that? It's different with what I'm teaching you. And of course, you can also find some Gaussian elimination method which is solving the equations like what I'm showing you just now in your slide. Okay, so there are two ways over here. But here I didn't teach you by up to this one, using this one, because as I say, to achieve this, you need to conduct rows operations for many times. Okay, so when I touch this for my students, right, basically we combine a few rows operations in one matrix, one step. Okay, so it can become very complicated. Okay, so the calculation will be much more complicated, and I found maybe this will be easier for you. Okay, there are multiple ways. Okay, sometimes. Okay, now, is that okay? Okay, then let me proceed to the last method. Okay, Cramer's rule. Okay, Cramer's rule. Okay, so I think the last method might be the easiest one. Okay, to solve. Okay, for the unknowns. Okay, so let's say, let me take the, okay, so this is the equations that we need to solve. Okay, so this is the simultaneous equations we need to solve. Okay, this is method 3. How we solve using Cramer's rule. Okay, how we solve using Cramer's rule. Okay, so remember previously we can write this equation as this, right? Okay, we can write it as the coefficient is, so can you see what we have here? Basically is the coefficient. Okay, so what you can see here, this value is the coefficient of the x, y, z. Okay, so we write in this matrix. So first we will find the determinant of the matrix, of this matrix. Okay, let's say we're using this delta as a symbol. Okay, it's a determinant of this matrix. Okay, so you should remember how to find the determinant. Okay, so how we find the determinant here, let's say we're using the values at the first row, plus, minus, plus. Okay, the value is 1, 2, and 3. So, okay, so now say I blocking the first column. Okay, first row and first column, so I have negative 3, 4, minus 1, and 5. Then for second value, I blocking the first row and second column. I have 2, minus 3, minus 1, and 5. Then come to the third value. Okay, so I'm blocking first row and third column, so I have 2, minus 3, negative 3, and 4. Okay, then I try to solve this, okay, to get negative 28. Okay, so I have negative 15 plus 4, then minus 2, then 10 minus 3, plus 3 times 2 times 4, 8. Negative 3 times negative 3 is positive 9, so minus 9. Okay, so we're using this one to get negative 28. Okay, so understand for the first step? Can you understand for the first step?
Yes, miss.
Okay.
Yes, miss.
Okay, now come to second step. Okay, second step, we try to find the determinant of x. So what is means by determinant of x? Okay, hold on. You need time to respond. Okay, so how to find the determinant of x? So we put the symbol as delta x. Okay, now we need to refer back to our equation just now. Okay, so can you see when refer to equation, right? This column is x, this column is y, this column is z, right? Can you see x, y, and z, right? Okay, when we want to find the determinant of x, the column of the x will be replaced it as a 533. 533 is a value at the right-hand side of the equation. Okay, 533 is the values at the right-hand side of the equation. Okay, so you are going to replace the first column, okay, as 533. Then the rest of the column of y and z is remain. Okay, okay, get it? Then okay, then we continue to find the determinant. Okay, then we proceed to find determinant. So how we find the determinant? Okay, so remember positive, negative, positive. First row is 5, 2, 3. So 5, 2, and 3. Then blocking first row, first column, we have negative 3, 4, negative 1, and 5. Okay, come to number 2. Blocking first row, second column, 3, 3, minus 1, and 5. Then followed by third values of 3. So blocking first row, third column, 3, 3, negative 3, 4. Okay, so now, okay, then you continue to find the determinant. So you have negative 15 plus 4. Then 3 times 5, 15 plus 3. Then 3 times 4, 12 minus negative 9, so which is plus 9. Okay, then you get negative 28. Okay, so you find the determinant. Then, okay, how we find the values of x, the unknown? How we find the values of the x? Okay, the formula is determinant of the x divided by the determinant of the matrix. So determinant of the x, which is the values we calculate just now, and this determinant, which is from the earlier step, okay, the determinant of the matrix. So this is a value. Okay, then we get the answer of 1. Okay, so we get the first unknown. Next, how we actually find the y? The concept is the same. Okay, we're using the same concept here. Okay, so now we want to solve for y, right? Okay, then remember second column is y. Okay, so for the second column, you are going to replace it as 533. Okay, we replace the second column as 533. Okay, then we proceed to find determinant. Okay, so we proceed to find determinant. Okay, so how we find the determinant? Okay, so we find the determinant as usual. Okay, so equals to plus, minus, plus. Okay, taking the values of first row, 1, 5, and 3. Okay, then taking the blocking first column, first row, we have 3, -1, 3, and 5. Then taking blocking first row, second column, 2, -3, -1, and 5. Blocking first row and third column, 2, -3, and 3, 3. Then you get the determinant of 28. Okay, so we get 28. Okay, so now done. Okay, then how we get the value? Okay, so determinant y that we just obtained divided by the determinant that we get in the first step. So we get this answer. And the same things we repeat on the z. Okay, we repeat on the z. Okay, so that means when come to z, we replace the z column as 533. Then for the rest, it still remain the same. Okay, then we find the determinant, we get -56. Then how we find the values of the z, determinant z divided by the determinant we find in the first step, then we get the answer of 2. Okay, so that's how we get the answer. Okay. Okay, now look at the questions. Okay, Samuel asking for third column, can we just use substitution? Are you trying to say that for the x and y values you obtain, you substitute back into the equation?
Yes, miss, because it'll be faster than finding the determinant of z.
Okay, my answer is like this, okay? If you are talking about solving the equation, yes, okay? You can solve it, not a problem. But if we are talking about solving it with Cramer's rules, then no. Okay? So if you're talking about solving by using Cramer's rule, so for the third unknown, you still have to continue with this one. Okay? Because when come to the assessment, okay, if you are talking about assessment, okay, so normally I will say the questions require you to use Cramer's rules. Then for all the x, y, z, you must show how you get to the answer using Cramer's rules. Okay, it's not mixture of other method. Okay, but if we are talking about just solving the equation, solving for the unknown, then of course you can use what you mentioned just now. X and y using Cramer's rules, then the z you just using substitution. To solve it, then it's fine. But for when come to the assessment, okay, if you are required to use Cramer's rules, please, all the x, y, z, you have to use this method. You get what I'm trying to tell you, Samuel?
Yes, miss.
And the reason also because I want you to really understand how to use these Cramer's rules to solve for 3 unknowns here. Okay? Okay, so we have done. Okay? So we have done matrices. Okay? So today we only go through 2 methods, right? Okay? So just now is solving using Gaussian elimination method, and I explained quite a lot already. And the second method that I go through with you is using the Cramer's rule. So when you solve using Cramer's rule, first we are going to find the determinant for the matrix. The matrix for the coefficient of the unknowns of x, y, z, okay, from the equation. So you solve for the determinant. Then you need to look for the determinant of the x. Okay, so determinant of the x means you must substitute the column of the x with the values of at the right hand side of the equation 533. Then you find the determinant of the x, then you solve the values of the x by determinant x divided by determinant. So you repeat the same things on the y and also for the z. Okay, so replace the second column, replace the third column, find the determinant, and solve for the y and z. You are repeating the same method for the rest of the unknown. Okay, this is the way. Okay, so is there any questions you want to ask for Cramer's rule? Is that okay? No, okay. I think you don't have much to ask right now, and you need to practice the question. Okay. So, okay. Yesterday we have done until questions 8. Okay, by using the inverse matrix method. So now you need to solve for the rest of the question, number 9 to 13. Okay. Questions 9 to question 13. Okay, questions 9 to questions 13. Okay, so when next week we will discuss about this. So when come to the discussion, you can see if I demonstrate, my rows operation will be different with the slides given. And it might be looks a difference with your own rows operation as well. Okay, so and you need to practice in order to understand. Okay. Okay, so questions from Sutesh. For the second test, normally how many questions will involve 3 unknowns, because I'm concerning about timing. Your second test is actually 1.5 hours. So I think most probably you will have all the 3 methods are being tested. Okay, so the 3 methods we mentioned just now, inverse, for 3 by 3, inverse, Gaussian, and Cramer's rules. Most probably these 3 will be tested. I think should be enough time.
Miss, can I use one of them only? Or should I use the 3 of them?
Okay, it depends on how I set the question. Okay, so say some of the question, I just give you the simultaneous equation. If I don't put any requirement, so you can use any method. But if I want to assess, okay, your understanding for the method, then I will put the requirement. Okay, if my requirement is say using Cramer's rule, you have to use Cramer's rules to get full marks, because I want to assess your competency on using the method for Cramer's rule. Okay, if Cramer's rules, but you're using other method, you may just get the answer, you may just get the mark for final answer. And normally for this type of the question, you can see the workings is a lot. So most probably the marks for each questions will be very high. And after you get the answer right, you can actually able to check your answer by substitute into equation. So you will know whether your answer is correct. If let's say no, then you need to check your workings. So when come to this, right, it's not difficult, but students may tend to make the careless mistakes. So you really need to take note. And if you're asking me, to be frank, last time your, for example, like your test, right? Now it's 50 marks, okay, with 1.5 hours answering time. But for your information, for previously, when they are having 2 quizzes, right, each quiz is actually 30 minutes, you know. 30 minutes in the total is only 1 hour. But now you have 1.5 hours. So if you're asking me, I think you have enough time to solve the question. Okay? So, yeah. I haven't set your questions for test 2 yet. Okay? But from what I see how it's actually assessed in the past with 2 quizzes, I can foresee, okay? So most probably at least 3 methods will be, almost 3 methods will be tested, or maybe at least 2 of the 3 methods will be tested. Okay? Okay, any other questions before I dismiss the class? 5:15 already. Okay, so practice the question. Now, all these engineering maths questions, you have to practice the question. Okay, because when I check the team, okay, so to be frank, some of you not really, if I'm talking about the yesterday class, yesterday class, can you see I do the discussion in the classroom during the class time? So suppose you can actually write down the solution and submit. But when I look at here, how many students are submitting? 9 students. And we have 14. Okay, so I find more students do not submit the work. So if you don't practice the tutorial questions, I'm very worried. Okay, so when come to some new calculation, definitely you need to practice and submit. So for those haven't submit, please submit it. Okay, if you're asking me how to do well for maths, please don't just watch the video. Okay, you need to watch and then you need to practice the question in order to understand better. Okay, I believe those score well, they must be practice the question. Okay, they must be practicing all the questions. Okay, else it's very hard for you to understand and score well. Okay, okay, so for the 2 methods just now, okay, you will understand better until you practice the question. And next week, Monday, I'm going to discuss the question. No worry, I'm trying to cover, these are only 5 questions, right? But we involve, the time to solve it is quite long, so I will try to cover every single question. So 2 hours should be enough to cover, and please, if you haven't finished, then you try to practice it at home, then we will discuss it in the next class as well, okay? Then if you don't know how to do it, then you just wait for my discussion on next Monday. So you don't need to ask me in the personal chat. I will still cover it in the next Monday class. Okay, so I think that's all for today. Yeah, Saad, after the class, after I end this meeting, you go to chat box. I will start a call with you in the chat box. Okay, personal chat. Okay? Okay, so students, I think that's all for today. I will see you next Monday again. And next week, we'll continue for the 3rd topics, complex numbers. Okay? 3rd topics. Yeah, complex number. Okay? Yep, okay, that's all. Bye, students.
Thank you, Miss. Bye-bye.
Bye-bye.
Thank you, Miss. Have a good day.
Yeah, same to you.
Thank you,
Bye.
Miss. Bye.
Welcome. Bye.
Thank you, Miss.
Bye-bye.